So, if I'm not mistaken, in 1995, a paper by Lewis, I will share this paper in our online website. So, he says that due to the presence of this cosine theta term in the denominator, this BRDF becomes unstable, let's say, or not energy conserving for very high incidence angles. So as this theta I gets closer to 90 degrees, the value of the BRDF becomes extremely large. Okay, so it is said in this paper that I haven't tried to validate it myself, but it says that this BRDF does not become energy conserving, basically. Okay, so it is he makes a modification to this BRDF. Okay, it's kind of interesting. He says, okay, let's just make this BRDF like that. Okay, let's clean these parts. Okay, and let's have this BRDF like this. Okay, just that. So F is KD plus KS cosine alpha R to the power of pi. Of course, when this becomes negative, when this goes greater than, when alpha R goes greater than 90 degrees, when this becomes negative, you must clamp it to 0. Okay, which means the light is coming from behind the surface. So this really is called, okay, as surprising as it may seem, this there's a name for this, and this is called the modified Phong BRDF. Okay, it makes sense, right? We modified the BRDF, so now it's called the modified Phong BRDF. And after this modification, it becomes possible to normalize this BRDF. Okay, so similar to how we normalize the Blin distribution. Now, the normalized version of this BRDF is the following. Okay, let me clean this part. Now, the modified Phong BRDF after normalization, and for normalization you do the steps that we have talked about for normalizing the Blin, similar to Blin microfacet distribution. Okay, so you use similar kind of integrals and substitution. After the normalization, the modified Blin Phong BRDF becomes the following. Becomes KD divided by pi, and then pi over 2 divided by 2 pi. Okay, so this should be familiar to you. And then we have, let's write Ks plus Ks times pi over 2 divided by 2 pi and cosine alpha r to the power of pi. Okay, so this BRDF is energy conserving. Okay, so this we can write this as normalized modified Phong BRDF. Okay, so it has, but we have this condition, right? KD, KS, their sum should be less than or equal to 1. Okay, so if their sum is less than 1, it means there is some absorption. If they are equal to 1, there is no absorption. All the incoming light is reflected. Okay, so this is the modified Phong BRDF. Now, how about the Blin Phong BRDF? If you want to compute the modified Blin Phong BRDF, instead of using alpha r, you are going to use the alpha h, the angle between the half vector and the surface normal. Okay, so I don't want to do the derivation, full derivation here, but by using the same approach of normalization, the modified and the normalized Blin Phong BRDF is equal to the following. It is equal to KD divided by pi plus KS. Okay, this time we have pi plus 8. Okay, pi plus 8 and then we have 8 pi, and we have here cosine alpha h to the power of pi. Okay, so this is the normalized modified Blin-Phong BRDF. Okay, normalized modified Blin-Phong BRDF.